Okay guys, so the other units have given you a bit of an introduction to what energy is, but we're going to cover it a bit more in depth and talk about the types of energy and their uses. But before that, we have to ask, what is energy? And look, pretty lights. Woo. Go ahead. To begin with that, we'll start with the textbook definition. Energy is essentially power. And in the way that we use energy, it's power used to do stuff. So the stuff that we want to do relates to transportation, municipal, which is, anybody know what municipal is?
Every day.
Yeah, work and home. And then industrial, which is basically getting more energy. Go ahead. And we talked about this a little bit when we were talking about the energy transformations and the different cycles and the natural cycles of energy. First law, energy can't be created or destroyed. There is an energy popping out of nowhere, and there is an energy popping into nowhere. And then the second, energy is lost when it is transformed, usually as heat. That doesn't mean it disappears. It just means that we can't use it anymore. Sorry, it's okay.
Now I just want to piggyback on what you said. If energy, really don't think of it as a cycle, because I think that question could come up. Think of it as a flow, okay? Because a cycle starts and flows into each other. Energy, even though the starting point is equal to the end point in terms of what you put in, you get out, but it can't come back into the system. So it's like a linear system, okay? It's not a cycle. And what I mean by the start point is equivalent to the end. Whatever you put in as energy, you end up with the usefulness. So by definition, what you can get out of it is what changes, okay?
So here we go with one of our first vocabulary words, which is energy efficiency. And in the way that we want to use it, energy efficiency is the measure of the useful energy produced compared to the energy that is converted, which is basically what Mr. Ringo said. We're dealing with how much energy is still useful for us. So it can be achieved by using more efficient technologies, which again, going into the prevention is always key. The goal of what we're going to be talking about is improving energy efficiency. And an example of that is using fluorescent light bulbs in place of incandescent, which is 20% versus 5%. And statistics and whatnot, but just remember that our goal is to improve energy efficiency, is to improve getting or keeping the amount of energy that we can use through all these transformations. Now, energy waste, which is basically the opposite of energy efficiency. This is what we want to try to cut down. The US unnecessarily wastes as much energy as 2/3 of the world's population consumes. So think about it. We waste as much energy that would power 2/3 of the world. About 84% of all commercial energy in the US is wasted. So lighting, municipal uses, and some transportation uses, depending on whatever. It kind of goes across all spectrums. And then, go ahead. Oh, sorry. For energy devices, like the light bulb, 95%, which we talked about before. Switching to fluorescent would be a better idea. The nuclear power plant, which we'll go into a bit later about how it's actually pretty wasteful. The engines that you use in your car for transportation, and then a coal-burning power plant.
I love this approach of prevention and then efficiency and then waste as the start of the introduction of the unit. Because that's what it's all about. It's how you're gonna prevent losing energy, how you're gonna make it more effective so when you use it, it has a longer lifespan, and how we're gonna eliminate the waste, the three biggest problems.
And so now I'm gonna hand it off, and there's a video at the bottom there, but we're not gonna be able to watch it, but that's okay. We're gonna be talking about two types of energy production, and we're gonna talk about the efficiency of them, how much they waste, what uses they take up, where they're found, some pretty cool things. We do have a chart for you that we weren't able to print out because we didn't know that we were going today, but we'll try to either put that on iTunes for you guys to make notes if you guys are reviewing. So we're gonna talk about two kinds, non-renewable and renewable. And just for a quick overview of them, go ahead. Non-renewable is 75 to 80% of the energy in the world, whereas renewable is 20 to 25%. Numbers go all over. We weren't able to pin down something. And then you have certain countries that are largest energy consumers and largest energy producers. Now, do you think that the people who consume the most energy are the people that produce the most energy? It's fairly close, but you're correct. One of the largest, we are one of the largest importers of energy, and we get our energy from all over, oil, etc. And that's another thing we're going to be talking about. Go ahead. Here's visual for all you visual learners. Look how much is non-renewable and renewable, just a tiny little slice. But hopefully with these different, methods of energy, improving energy efficiency, that number will grow. Yes, Sophia?
Sorry.
Okay, cool. Go ahead. And then here we go with another visual. We're going to be breaking down the non-renewable energies into particular little categories. And this chart should actually be later in the presentation. However, this will give you a better idea of once you see these things come up, like oil and coal and biomass, you can kind of try to keep that visual in your head of how much of the world's energy consumption actually goes. So now we're going to break down those different individual parts of non-renewable energy, and we're going to start with Jason.
So, non-renewable energy is an adjective relating to a natural resource, such as petroleum or a mineral ore, that cannot be replaced once it has been extracted or procured. What this means is, once you've used a non-renewable resource, you cannot get it back under any conventional circumstances. It would take millions and millions of years for more oil to form in the same sense that we have oil today. Next. So there are 4 types of non-renewable energy. There is oil or petroleum, natural gas, coal, and nuclear power.
You gotta love those little icons, yes? They're like little apps.
Yes. Where'd you get it?
She found them. It was a very exciting moment for her.
It was.
So, oil. Oil is formed under heat and pressure over the course of millions of years from little bits of mass from plant matter and fish and other animals from millions of years ago. It is currently about 40% of U.S. energy, although the U.S. only holds about 2% of the world's supply. So we import a pretty good amount of our oil in order to keep us running, which is bad. The Middle East, however, has a little less than 50% of the supply. More than 50% of the supply. Crude oil or conventional oil is made of hydrocarbons with traces of sulfur, oxygen, and nitrogen. So it has a full chunks thing. So we get our oil, in the US at least, primarily through ocean mining.
Hold on, let me go back here for a minute. So, you said it formed millions of years ago. You talked about the plants and animals. Where did this take place, mainly?
What do you mean?
What type of environment? Ocean.
Oh, ocean.
Okay, and what happened to them that they were able to go through this fossilized process?
There are actually 2 main theories right now. There's the heat and pressure theory.
Okay, that's good enough for me. They
Okay.
subjected to heat and pressure, and they were compacted and buried. Okay.
What's the other one?
I'll get into that when we go over natural gas. Anyway, so there are 2 main methods of retrieving oil, at least in the US. It is primarily through ocean mining. It is transported via pipelines and trucks, refined into different parts based on boiling point. The highest boiling point is used for fuel, and the lower boiling points are used for industry or production of oil-based
Beautiful
goods.
explanation. I'm in love with it.
Thank you.
It describes the whole refining in a whole different way. This is why I say, if you read another resource, you hear it a different way. I've never heard it this way, yet I try to say it, and I don't even say it this way. This explains the whole process of why petroleum is refined. The high boiling points for energy, the low boiling points for industry. Beautiful.
And the other main method of retrieval is a very bad method of retrieval. It is through oil sand. Oil sand is a mixture of clay, sand, water, and oil, and is now considered a conventional oil. It's mainly located near forests and requires mining or digging, which can lead to many environmental problems. The main producers of oil in the United States is Texas, then Alaska, California, Louisiana, and Oklahoma. The majority of it is controlled by the government or private corporations. The government holds it and private corporations sell to us. It's mainly used for transportation as gasoline, diesel, and jet fuel, and we use about 26% of the world's oil, of the world's consumed oil per year. So, oil use is about 47% gasoline, 23% heating and diesel products, 18% oil-based products, and about 10% jet fuel.
Why isn't the diesel application? Why isn't that lumped with gasoline considered?
Because there's many types of petroleum fuels. You've got jet fuel, kerosene, gasoline, diesel, they're all different. So when it's refined, you cannot use kerosene to power a car, correct? So even though it's a type of fuel, it's a fuel used for lighting. So the fuel efficiency and its ability to move a vehicle or move a jet varies, yes? So that's the difference.
If I may interject, going in on what Jason said about the boiling points, gasoline is like a more pure form of energy. Whereas diesel, it's not necessarily grouped with that because it's a lower boiling point, so it's considered down with the ranks of the heating because it's the similar like rate with the heating scale.
Are you sure about that?
I'm pretty certain.
Because diesel is actually more efficient per mileage, so
Well, that depends on what engine you're using.
well, you can only use diesel fuel on a
Diesel
diesel engine. I'm actually not sure about that in terms of boiling points.
Diesel is easier to combust. Usually in cars, many of you have heard of spark plugs. In a gasoline cars, you need a spark plug because the compression, you still need to light it, while diesel, if you compress it, it will actually blow on its own. So in that sense, it has a lower boiling point.
Okay. Why is it more efficient then?
They don't use like spark plugs, they use glow slugs just to constantly
Maybe
hot.
Okay.
It has to do with the actual
Me
engine
in cars,
itself.
I don't even know what car I drive sometimes, but yeah.
Wait, the German car business?
Yes.
Okay.
I'm the finance behind it.
So then, in review of oil, we have developed technology around it so that it is.
Wait, I can't believe all that came out in the video. Go.
So, in review, there are the pros and cons of oil. The pros are we have developed technology around it so that it is generally fairly efficient in the use of it through transportation and industry and electricity. It is abundant in terms of other energy sources, and it has a high heating value. It's easily transported, unlike some other forms of energy, and it's relatively cheap.
What do you mean by abundant?
Abundant, as in it can be found in a lot of places.
I would have to say no to that. Only because of and maybe there's a lot of ways to look at this and what does abundant mean. But if you're gonna compare energy, petroleum is the least abundant. Okay, so we want to try to focus on that because it's the one that now, if we're talking about the new, what they call the new conventional oil, that increases the amount of petroleum by far to other forms of energy. But that is a whole other topic on its own. So if you think of petroleum, think of it as the least abundant, okay?
I think what they mean is that like previously it was like really considered abundant. Like you could just like some people could just like dig and they struck oil like
I guess.
that.
All right.
Maybe a better word to replace it would be easily accessible.